So in this example, we have a polynomial in x cubed, limits between 0 to infinity. So if we do this using the calculus of residues, then the contour we want is a sector-shaped contour where the angle is 2 pi over 3. So it's a sector-shaped contour, radius r. So, as usual, we consider the limit as goes to infinity. Always label the contour. dz over 1 plus z cubed. Okay, so from here to here, as r goes to infinity, that's the integral I want. Around here, I've got the limit as r goes to infinity from 0 to 2 pi by 3, and dz, well, here I've got z equals r e to the I theta. So dz is r e to the I theta I d theta, and on the bottom I've got 1 plus r cubed e to the 3 I theta. So no problem, this goes off like r to the minus 2, which tends to 0. And the last bit is along here. So I've got plus the integral from along here, I've got z equals r e to the I 2 pi by 3. So the integration variable now is little r, which goes from infinity to 0. And my dz is now dr times e to the I 2 pi over 3. And on the bottom, I've got 1 plus z cubed. But 1 plus z cubed is 1 plus r cubed, and then this cubed is just e to the I pi. So I just end up with 1 plus r cubed, which is basically the integral I want. So in the end, I get 1 minus e to the I 2 pi over 3 times the integral I want. Now, this is going to be equal to the residues of the poles inside. So I need to find out where the poles of this are. So z cubed equals minus 1. Okay, so if I take the cube root of that, there's sort of a shortcut. You realise that, of course, there are 3 roots to this, but I know that they're on an equilateral triangle, and equilateral triangles have angles of 100. They'll be 102 by 3 degrees apart. So I only need to find the one which is here. And the one which is here, I just divide by 3 and I get e to the I pi by 3. So the only pole I need is the one which is here, which is e to the I pi by 3. So the pole I need is zj equals e to the I pi by 3. So I need to work out the residue at that point. So anyway, I'll write something down. So I do the residue first then. So the residue of 1 over 1 plus z cubed at e to the I pi by 3 is equal to, use the p over q dash method, so we've got 1 over 3z squared, so it's 3, and then this thing is squared, so it's e to the I 2 pi by 3. So, my 2 pi I times something. Okay, so my final answer then is, this is 2 pi I times the residue. So I've got 2 pi I times the residue, which is 3 e to the I 2 pi by 3, and then divided by this. So it's divided by 1 minus e to the I 2 pi by 3. Now, we can't just leave it like that. We need to do a little bit more work. So, multiplying out brackets, we get 2 pi I over 3 e to the I 2 pi by 3 minus e to the I 4 pi by 3. Now, the trick here is to realize this looks something like, it looks a bit like it should be sine, except if it were going to be sine, then we would expect to have a minus 2 pi over 3 here, not. But you see, actually, we're always free to add or subtract 2 pi to this. So you see, if we, in other words, 6 pi over 3. So if we subtract 6 pi over 3 from this, then we'll get e to the minus 2 pi over 3, which is precisely what we want in order for it to get to look like sine. So this is equal to, just another way of writing it, 2 pi I over, sorry, should be brackets here. Minus 2 pi over 3. So, this bit here is precisely 1 over sine 2 pi over 3. So that just leaves us with pi over 3 sine 2 pi over 3. And sine 2 pi over 3 is root 3 over 2. So we end up with